And the other thing is it's Grant and his wife, because, you know, families and everything. So, there's variations on the correct answer. So, but it's, you know, it's a place you can, next time you go to Manhattan, make sure you visit Grant's tomb. That's where it is. Okay, so can I write X in terms of base B and G? So what? So B to the X equals G, right? What's that equivalent to in terms of logarithms? Log X equals log to base B of G. Okay. So for X, I can substitute that. So this is equal to log to base B of G. And same by the same token, you know, B to the Y equals H. That's equivalent to saying Y is equal to log to base B of H. So for Y, I can write. And so there you go. It kind of reminds me of, like, anybody solve the cube, Rubik's Cube? Yeah, a couple people.
Only one side.
With the single side, yeah. one cube, yeah, yeah. The 3x3 is a little harder, yeah. So if you solve the cube, you know this business of like a conjugator, where you like turn everything so that when you make that move, you don't upset what you have, and then you undo those other things. So that's kind of what this is, right? So we turn everything so we can make this move, and then we undo it again, and we're back here. So the log of the product is the sum of the logs. Shall we have an example of that? How about log base 10? That's the common logarithm, right? So log base 10 of, I don't know, 1,000. So this is an obvious number, right? What number is it? 3, right? 10 to the third power. So this is 3. But I can rewrite it as log base 10 of 10 squared times 10 to the 1, right? So I've got it now as a log of a product. 100 times 10 is 1,000. And then I can say, well, this is the sum of logarithms. Log to base 10 of 10 squared plus log to base 10 of 10 to the 1. These are both Grant's tomb. Like, what power do I raise 10 to get 10 squared? Well, that's 2. What power do I raise 10 to get 10? Well, that's 1. 2 plus 1 is 3, right? So it works out. It's a quick, easy, obvious example of how this works in general. Or in a particular case, it does work in general. All right, so how about this other one? Can we also prove that one? Well, let's save that one for next time. But it's kind of handy. I haven't said what the equivalent, so what's the equivalent logarithm? Well, this says that log to base B of G, G to the Y. Yeah, let's say G to the Y. So I'm taking G, raising it to the power Y, and then taking the log to base B of that, right? That's the order of operation. So first the exponent Y, then the log. And it turns out that's exactly equivalent to saying Y times log to base B of G. So power to the power is the product of the powers. So here we see if we take a log of a power, that's the product. And so that sort of answers the question, what do you do if you don't have log base 10 or log base E, right? Then you can't use your calculator directly, right? So if you want to solve an equation like this one, 2.61 to the t equals 250. Well, we said log to base 2 points, so this is exactly equivalent to saying t is the exponent, which when applied to base 2.61 gives me 250. Yeah, but I don't, oh, sorry. Wrote that badly. T is the exponent. A logarithm is an exponent. So what exponent is this? This is the exponent which when applied to this base 2.61 gives me 250. An awkward notation, right? This word log is kind of, they could have called it anything, right? Fred. We just settled on this logos plus, they're into Latin and Greek and that sort of thing. So if you wanted to sound erudite, use Latin and Greek names. But we can't, how do you evaluate this using the change of base formula? So how do we get the change of base formula? Well, let's do it here. So we start out with 2.61 to the t equals 250, right? That's our starting equation. So now remember, a logarithm is a one-to-one function because it's invertible. The inverse of a log is an exponential, vice versa. So it's one-to-one. So this is true if and only if the log to base, 10 or e? Let's use e. 2.61 to the t. Well, I should write it like this so it's clear what the order of operations are. Equals the log to base e of 250. Now notice I'm using log to base e instead of ln. They're the same thing. ln is log to base e. It's nice to be explicit about what the base is. So if you use log to base e like this, that's unambiguous, right? It's base e. So now what does this second property allow me to do now? This property of logarithms here. I can take that t that's in the exponent. So the input to the logarithm is raised to the power t, right? Instead of raising the input to the power t, I can multiply the output by t. So I can say this is t times log base e of 2.61, right? So you can take that power inside the input and multiply the output